Hi and welcome to today's edition of the Bare Basics. Today we're going to do a brief introduction to the unit circle, which many of you in my class would have made in class. We're going to look at what it is, why it's called the unit circle, and how we actually can read it when we know the angle that we are dealing with. Okay, so let's begin. Let's look at what exactly is the unit circle, and I'm just going to pause the video for a moment while I load it up because I'm going to give you an image of the one that we made in class. Okay, I'm back and here's our unit circle. Now the only difference between the one here and the one that you made in class is that you actually had a paperclip to use as your guide for the circle and what angle we're using, and I have a rubber band. Otherwise, we have the same thing. We have a circle, okay? Now, it's called the unit circle because the length of our radius at any point in time is considered to be 1. So it doesn't matter what size we actually use, as long as we class our radius as 1 and we can divide our circle up into equidistant parts, then we can use it as a unit circle. So what we've actually done is we've overlaid our circle onto a Cartesian plane with the center of the circle at the origin of the plane. Because it's a unit circle, when we go out along the x-axis, it means that our circumference would be on the point 1, 0. Then as we trace up, it would be 0, 1 on the y-axis. As we come around, it's at -1, 0 on the x-axis again, and then it comes down to 0, -1 on the y-axis. So you can see quite clearly that on the Cartesian plane, that is a circle with a radius of 1. Now we divide our unit circle into quadrants, and we class this point here as our starting point, and then we read when we put our circle when we've gone around and we've divided it into 15-degree segments, which we did in class, so we've got 15, 30, 45 and so on. We do that because it actually helps us to plot the graph of what we're going to see, and we do it so we can easily read it. So we start here at 0, so between 0 and 90, we call this our first quadrant, and these are done conventionally in Roman numerals. When we come between 90 and 180 degrees, this is our second quadrant. Our third quadrant is between 180 and 270, and our final quadrant is our fourth quadrant. We will refer to these as we are doing our various calculations and so on, and when we get more into looking at the unit circle from sine and cos point of view. Okay, so this is the unit circle. Our next step is how we actually read the unit circle. Okay, here we go, and we can now look at reading our unit circle. So let's have a look at, say we want to define the angle of 45 degrees. So here we're at 15, 30 and 45. So what we're going to do is, in this case, I'm going to take my elastic band up to there. And in your case, you would take your paper clip. Now, we can consider this a right-angled triangle because we have our hypotenuse, which has a length of 1. And then we can drop down to our x-axis and then go back across to our origin. So that's our right-angled triangle, which has an angle of 45 degrees in here. Now think back to what we know about our triangles. And we know that sine of an angle is found by using the opposite over the hypotenuse. So if we take the length of our opposite side over our hypotenuse, which has a length of 1 for the unit circle, it means that sine of the angle can be found by simply taking the reading of the vertical height. So in this case, if I go across here, my vertical height, so here, I'm going to read that across. So sine of 45 degrees is around 0.7. Same can be said with cos. So let's look at 60 degrees for cos. So we're moving up to our 60 degrees. So we've got 15, 30, 45, 60. And we've got our horizontal here and our vertical here for our right angled triangle. So our cos, here's our angle, our cos is our adjacent over the hypotenuse. So once we drop this down, our adjacent length will be a half on 1. So cos of 60 degrees is a half. And that's how we can read our unit circle. Now it works the same when it's on the negative side. So if I come over here to the second quadrant, now I can read this as 120 degrees. Okay, so I've got 90, 105, 120. This time, if I drop this down and I'm taking it from the origin out, so for 120 degrees, our cos takes us to negative 0.5 on 1, so negative a half. And once again, our sine, which will be the vertical height, is around, if I can read that, so it will be around 0.87 because it's between 0.8 and 0.9. That's how we read our unit circle. So once we know our angle, we can get an idea of what our sine and our cos is of that angle simply by taking the vertical height for sine and the horizontal reading for cos. Okay. This has been the bare basics on an introduction to the unit circle and reading your unit circle. If you have any questions, just ask me in class or shoot me an email. Remember, the idea of the bare basics is to make maths that little bit more bearable for you.